So thank you all for coming this evening for our Retrofit Meets University Estates event. This is the 6th event in our Retrofit 24 public programme as part of our programme of works looking at commercial, cultural and civic retrofit projects linked to the exhibition upstairs. I'm Laura Broderick. I've been working on the curation and the delivery of the events programme. If you haven't had a chance to look upstairs at the exhibition, hopefully you will be able to stay a little bit after tonight's event and kind of mosey around that. We are due to finish today's panel discussion at 7:30, and then we will be closing the building at 8, so you'll have a little window to look around, hopefully. So the events, panel discussions, I'm not chairing this evening. We do have a chair who I will introduce shortly, and she in turn will introduce all our speakers. But just to say thank you all for attending, thank you for participating in the discussion. We will have a Q&A after each presenter has finished their 10-minute slot, so we won't take questions in between speakers. We'll save it till the end when they will all sit together on stage and you can pose your questions to them. So we very much want to hear about your experiences of working on retrofits in university sector, and whether you're delivering projects as an architect or another built environment professional, or whether you come from an estates facilities viewpoint or work in a university. It's all a kind of discourse and collective action that we would want to kind of gather from you all tonight. I know I'm very excited to kind of hear the case studies, the three case studies that will be presented are all also in our exhibition upstairs. So we'll be hearing about the Bartlett School of Architecture, we'll be hearing about London South Bank University and their London Road building, and then we'll also be hearing examples from University of West London. And very much the fact that we have got quite a lot of universities in the exhibition upstairs was very much driven by our partners and the content and the projects that they were working on. When we were putting the exhibition together, we were talking about projects in people's portfolios, workloads, and actually those university projects were kind of being talked about a lot from our architects, our engineers, our product manufacturers. So we know it's a really important aspect of the decarbonisation and achieving net zero debate through the built environment. So yes, we'll have all those presentations, all those case studies to learn from, and then your experiences to add to the mix. There are a few seats at the front if anybody's happy to come forward before the key presentations start. So to set the scene for tonight, we do have Professor Aylin Orbasli of Oxford Brookes University chairing the session. So I will introduce her. She is a researcher and a teacher focused on the historic built environment, including adaptive reuse and heritage management. Aylin is co-founder and former subject coordinator of the MA of International Architectural Regeneration and Development. She teaches theoretical modules, supervises masters and PhD level research degrees. So I will hand over to Aylin to chair tonight's session. Thank you, everyone.
Great. Well, thank you very much, and it's a great pleasure to be here. Oxford Brookes University is this year's educational partner of Retrofit 24. By virtue that we've been teaching adaptive reuse at the university, not myself personally, for 30 odd years, and myself for 20 of those at least. So we've been plugging it way before it became trendy, say. But what is it about the university? Why is there a separate session on the university estate, and why does it stand out, and what's special about it? And I think that got me thinking as to sort of what is this estate? It's often a sort of mixture of buildings, inherited ones, colleges merge, some are spread out over cities, other are on sort of neat campuses. They include all sorts of functions and uses: labs, studios, lecture theatres, sports facilities, cafeterias, housing, all types of different buildings within one estate, and the responsibility of usually one estate manager, who might describe some of it as sort of quite burdensome, not to mention sort of buildings of different periods and construction materials and so on and so forth. And of course, at the same time, higher education is changing, and it's changing very rapidly post-COVID, but there were sort of things that were happening before that. So what it means to be in a university space is changing how we teach, how we learn. On that, we're still questioning it. I can't say there is an answer yet. But for an estate, for a big sort of chunk of real estate, turning around and catching up is not easy. You can't turn it around as quickly as we can sit in an office and think, oh, this is what higher education is going to look like. So that's, I think, one of the biggest challenges of university estates is how you adapt them going forward in an actually very fast-changing environment. And then, of course, if you've probably been following the papers, we're in under huge financial pressure at the moment with universities. So money matters, and estates costs are a huge part of our running costs. I mean, when I put in research bids and I have to calculate overheads, estates come in as a big chunk. So it costs a lot of money to keep these buildings maintained, heated, cooled, and the rest of it. So any efficiency that can reduce that bill is always going to be welcome, and that. But we're also places of education, and we need to maintain. We have a mandate to train and inspire future generations. So it's really important that we also set an example by what we do with our estates. There's no point teaching sustainability or decarbonising when we're not doing that on our own home turf. So I think it's also an important part of the messaging and action by doing that universities are both obliged and feel important is to do. So I think those are where I would start off this discussion, with stating where we stand with the university estates. But we have 4 amazing speakers and 4 very interesting case studies to look at as how the university estate or buildings within a university estate are adapted and changed to match sort of new uses. And we're going to start from an architectural journey through to structural engineering, and then into the services and how we keep these places both warm and cool. And that. So our first speaker will be Tom Noonan from Hawkins Brown, where he leads a studio and along through a wide range of projects and sectors, including award-winning projects. He's led several education projects at UCL, University College London, including the remodelling of the Bartlett School of Architecture, many of you might be familiar with, and is obviously also the subject of his lecture today. He's also been working with the Department of Engineering on a new facility at Here East that provides new space for academic programs, robotics, fabrication and engineering. And he's also currently working with the life sciences sector. So that will be about buildings and how architecture and the role of architects in adaptation. Tom will be followed by Duncan Walters, who's a structural engineer with Eckersley, O'Callaghan and Structural Engineers, whom he joined in 2014. Prior to that, he was a skilled steel fabricator and toolmaker, and that led him into a transition into structural design and consultancy. And he's known for his conceptual design expertise. And what sort of appealed to me is an effective communication with architects as well as clients. But I think that's always nice to hear. Maybe as architects, we're the ones who are challenged. And he's also been looking at leveraging design tools for structural efficiency and sustainability, some of which you're going to hear about this evening, including smart massing tool, rapid prototyping tool, and promoting sustainability through EOC and ECO to EOC or right. Okay, right. Okay. They're plugins for Revit. So he will be talking about the work they've been doing at London South Bank University in a sort of quite a substantial project. That was our third speaker. Now moving into the services on the building is Guy Ransom, who's the commercial director at Geotherm, which is a leading heat pump supplier and installer. He's originally studied accountancy and economics, but then moved into heat pump technology when he started exploring replacements for his own very aged gas boiler. So we should probably, but anyway, he's going to, he's 20 years experience in finance and senior management, and he will be talking about using heat pump technology at scale through the example of the University of West London, University of West London, the Paragon House building. And our final, not last but not least, speaker is Emily Sherrill-Ambus, who's the National Key Account Manager at Panasonic Heating and Cooling. She also has a degree in physical geography and mainly works on public sector housing projects as well as university projects, helping organizations reach their net zero targets. And her current work includes breakthrough research projects with leading universities and delivering on numerous retrofit projects across the UK. And she will particularly be looking at heating and cooling solutions on university estates. So I pass on to Tom. The speakers have 10 minutes each, and we'll do the question and answer sort of panel session after that.
Format, so I'm going to have to jump to a different program here. There we go. Okay. Just gonna. I know I'm just trying to see the screen. Okay, so the Bartlett School of Architecture, 22 Gordon Street. This is a 40-minute presentation condensed into 10 minutes, so it's going to be pretty quick fire. Previously known as Waite House, some of you may be familiar with it, houses the Bartlett School of Architecture, and it has done for the last few decades. This is it in 1975, so it's just up the road to the north side of Bloomsbury. A pretty anonymous building, not the sort of highest quality. It was originally designed for around 300 students. School of Environmental Studies, pretty sort of cellular office-based accommodation. A few other views, and this was in 2014. So this was a year after we started working on the project, and the building in which I also studied. Didn't change much, not a huge amount of investment, and needed a lot of work to accommodate the ever-growing needs and scale of the School of Architecture and the Faculty of the Built Environment, and also the changing way that it was taught or has been taught over those years as well. So a few snapshots of how we found it in 2014. These were the studios. Pretty enclosed spaces. They fostered a lot of creativity and a lot of competition as well. Lots of closed doors. You didn't really speak to your neighbours. Not a huge amount of collaboration beyond the studio walls. This was the ground floor space. Windows boarded up for additional pin-up, so no real connection to the city. No real sort of communication beyond the building about what was happening within it to the wider public realm. Pretty drab seminar rooms where they greeted sort of, international academics for meetings, pretty uninspiring. Internal computer clusters, so pretty poor ventilation. I mean, the building was incredibly poorly performing, as a lot of buildings of this era as well, environmentally. And then academic offices, which, like most academic offices, look a bit like this. And then the workshop in the basement, not a sort of natural place to have a workshop for woodwork and metalwork and fabrication, but a really important sort of cultural asset for the Bartlett, and was a key part of the brief in retaining it. This was the adjacent courtyard space, which was used as spill out and also doubled up as an event space for Christmas parties and summer barbecues. And then the library on the top floor, which had amazing views, was one of the best spaces in the building, really, but was also falling down, actually. So big problem, chronic shortage of space, a growing school, changing technology, changing pedagogy, and not really a building befitting a school of architecture like the Bartlett. So we came on board in 2012 to try and originally appointed to do a very sort of light touch internal refurbishment. We went back to first principles. We worked really closely with stakeholders in the Bartlett, so students, staff, academics, and UCL Estates, to try and unlock more for the project, really, and deliver a slightly longer-term solution rather than a sticking plaster approach. We were constrained by the site, its conservation area, which straddles 3 sub-areas of the Bloomsbury Conservation Area. A relatively constrained footprint as well, and we needed to double the usable area for the school. So we went from just under 3,000 square metres of usable area to over 6,000. Importantly, obviously, the culture of the Bartlett is founded on the unit system that was brought in by Peter Cook, and there was a sort of need, a key part of the brief was delivering one workspace for every student. So supporting this very sort of unique way of working where, students would essentially live in the building and be able to sort of not be inhibited by their environment really, and have enough storage and desk space as well. So there were lots of facilitating projects. This sort of snowballed into a few other projects. Aylin mentioned Here East, which completed a good few years ago now, but it's still evolving. So this was a collaboration with the School of Engineering or the Faculty of Engineering and the Built Environment to deliver large sort of prototyping space for fabrication and testing and robotics. The library was moved out to a more a faculty building, central house, and then there was a temporary decant. So the building was decanted to Hampstead Road, which was an industrial building, blighted by HS2, but gave a great opportunity to prototype and sort of test bed new ways of working, to sort of break down some of the barriers that existed within the original building, to try and encourage a little bit more interaction between studios and staff and academics. So a lot of the furniture that we delivered in this temporary building was essentially a sort of it was moved back into the actual final project in Waite's house in Gordon Street. Okay, some of the key moves. It was a very inward-looking building, no real connection to the public realm. It was very cellular, racetrack circulation around the central cores, quite disorientating as well. No real daylight, no connection to outside. One of the key things was to take back the existing facade and retain as much structure as possible. I'll come into some of the reasons for that a bit later on, but it was a key part of our sort of design proposal, and then max it out in all directions as far as the planning envelope would allow, really. So we extended about 1.5 meters around the full perimeter of the building, replaced the falling down fifth floor and added an extra lightweight fifth floor on top. This was all with the existing structure, which was pretty low quality, didn't have a great amount of capacity, and some foundations that we couldn't really do anything to. It was a big raft slab, so all incredibly lightweight extensions, but delivered over double the usable area for the Bartlett. A few key insertions, key spaces, double height spaces, connecting the building to the city and creating a bit of respite from the intensity of studio and office space, and a new staircase that linked an extension to the south and provided this sort of social generator through the building. We wrapped it in a more tactile and natural inner lining, so everything extended around the perimeter was wrapped with timber. And then this sort of contextual wrapper, so a traditionally laid brick envelope to try and reflect and respond to the historic Bloomsbury context. It was a very lightweight brick. It was a sort of 2/3 of the normal depth of a brick, bespokely made because of the limitations on the structure as well. Some kind of high-level stats here, around just over 1,300 square meters or cubic meters of concrete retained, the equivalent of about 260 double-decker buses. And I think in terms of there's an obvious embodied carbon saving there as well, which was coupled with sort of the operational benefits and energy and use benefits of a new facade as well, in terms of airtightness and thermal performance, that stood this new building or deep retrofit in good stead against a typical new build as well. A few images of the work in progress. So you see the sort of the very sort of deep retrofit that was undertaken. We inserted a double height space at ground and first floor for an exhibition space and cafe to try and connect the building with the wider environment. We went from around 300 desks and 60 offices to about 1,000 desks and 120 offices. So with that, there's obviously the environmental uplift that's required to service that. So put in some pretty chunky risers through the building to try and accommodate the ventilation and heating and cooling needs. So it's a mechanically serviced building, but also has openable windows throughout. So it's a mixed mode ventilation strategy. A lot of temporary propping, a lot of complexities on site. I won't go into it now, but one of the key challenges was the existing structure and the limitations of that existing structure. So everything that was added had to be super lightweight. It was steelwork and crinkly tins, plywood decks, but it maximised the building envelope and the area required for the Bartlett. Ground floor was one of the, there's a key sort of interface between the public realm and the and the Bartlett, so trying to open it up as much as possible, invite people in. The summer show, which used to happen at the Slade, or had done for the last 20 years, Slade School of Art, was brought back to the Bartlett for the first time in a number of years, with this much more open and connected ground floor. Cafe, trying to welcome the public in as well, pushing back the secure line, creating a shop front for the Bartlett, so trying to create and advertise and publicise the great work that they do. Encouraging collaboration, so a key part of that was a new staircase, and also these new big landings, essentially we call them, these spaces off the staircase, which we left pretty much unprogrammed, that have been appropriated by the staff and students over the last 5, 6, 7 years in different ways, for crits and for seminars and for pin-ups and exhibitions. There's a snapshot of the stair, and then this sort of articulated roofscape. So I mentioned the conservation area. It straddles, well, to the east it's Georgian Bloomsbury, intact Georgian terraces. To the west it's institutional UCL Bloomsbury. So the roofscape had to subtly sort of change to provide a different sort of articulation on both of those sides of the building. So you see the Bloomsbury end here in relation to the listed terrace next door to it, sorry, the eastern side. Spaces to learn, so trying to make as many connections to natural daylight and nature as possible in a very intense environment. Admittedly, it's still very densely occupied, but trying to offer as many sort of moments through the building for a bit of respite and a bit of perspective, really. Retaining sort of traces and memories of the past as well. So despite the flaws of the original building, it still was a really sort of nostalgic place for a lot of staff and students. They could do whatever they wanted with it. So we were very keen to try and retain that memory of the existing building and complement that with newer, more natural tactile materials. This was a stair core that we extended, so retained. There was actually one stair core painted blue and one red originally, so that people knew what side of the building they were in, because there was never any view out, so you're constantly getting lost. Connections to the city as well, and these dual aspect spaces to try and deal with some of the sort of weak corners of the original building that were fully glazed. And views into the school, importantly, and connections to the wider city. And then just a few before and after shots. So this was it in 2014, and this was it after completion at the end of 2016. Okay, so why retrofit? I mean, it's fairly obvious, a lot of these, but just to sort of recap. 1 minute. This is my last slide. This is absolutely perfect. Brilliant. Maximise the site's capacity. So pretty low floor-to-ceiling heights by today's standards, but they work. If we had demolished a new build and built new, we would have obviously sort of increased the floor-to-ceiling heights. We wouldn't have been able to get as much area because it was the envelope was maximised in terms of planning. Retain the school's identity. It was 6 months faster to keep the existing frame and demolish it and new build. It was £10 million cheaper, so some tangible benefits for estates, but also, most importantly, the embodied carbon savings and the reduction of waste and the reuse of materials. And that's it. Okay. I don't know how to do full screen. I'm not PowerPoint savvy, unfortunately. But
okay, thank you. Right. So I'm Duncan Walters. Thanks for the introduction, Aylin. So I work for Eckersley Callahan, and just to be clear, we're structural and facade engineers. We like to have a frame and envelope. It's the kind of nice to have that whole package there for then the other stuff to happen inside. It's kind of clean break. And we really put a lot into our buildings. We work on a diverse range of buildings, and I'll be honest with you, not all of the projects you see here today are all purely university estates projects, but bear with me, they're all about adaptive reuse, and then we finish with a case study that is very much university estates led. The things we like and things we're interested in, if you know anything about us, we did a lot of work in structural glass. We're interested in material innovation, sustainability, digital design, All of our projects are BIM, so all 3D modeled, and circularity. And I think at the moment with timber, fire, regenerative materials, adaptive reuse is the kind of richest period of what is kind of the built environment, I think. And it's an amazing kind of discourse that's going on. So it's brilliant to be involved in that at this point in time. We get involved in all different kinds of materials, from natural bio-based through to man-made, and then really engineered materials, and trying to push the state of the art. We've learned a lot, and a lot of people have learned a lot. The last 5 years has been a big push on sustainability and what the material approach is going to be. And I thought it was going to be this perfect world of new build projects. I'd been doing 15 years of refurbs, and I thought we'd clear that out the way, and we got these nice, easy new builds to do. No, that is not going to happen, because the most important buildings are the ones that we're refitting. Another sideline is we were trying to sell regenerative projects, and we realised that pushing timber was very difficult, because the QS would always say, well, I don't know, it's going to be expensive, and you really had to have the right kind of client to buy into the idea. So we started to kind of look at program, we get a QS in, we get the project managers in to try and understand kind of in funding terms. Maybe if we look at understanding the time to market and the rents that you can achieve, and different aspects, trying to find the sweet spot in the projects we were working on. So adaptive reuse, I Googled this. This was what Wikipedia told me. We do a lot of adaptive reuse projects. It's very forensic. You have to get in, you have to drill into the existing information, understand what the potential is in the building. We try and offer as much as we can, even if the planners and the architects and everyone's saying we only want one, we'll try and offer as many as we can, because it's about understanding where the capacity is, ideally without doing any work to the foundations. There's Panther House, East Road, LSBU in the corner. That one's Soho House in Brighton, where we put a couple of floors on top of an 1890s building that, effectively it sits over the shark tank in the Sea Life Centre. It's quite an interesting one. And another office infill, an extension of an atrium courtyard space. These projects tend to be very successful in terms of their upfront embodied carbon, because we are adding area, adding GIA, adding net increase, but not doing too much to the building, keeping most of it there. It's a bit of a slam dunk, really, and that's kind of what these metrics are telling us. There's East Road. We are putting lightweight Bartlett on top of existing buildings and seeing what their potential is. And we often get the geotechnical guys. We would outsource very high-level geotechnical inputs, so that we can understand, well, if we strip the building frame back and we add 3 floors and the building sinks a bit, it's okay, because we haven't put the facade, we haven't put the brittle finishes back on. So it's about understanding where the real sort of potential lies. We do a lot of historic heritage stuff as well. This gets quite high risk and quite nervy when there's a kind of what they described as a priceless fresco on the wall behind, and then they're insuring the building for £100 million while you're doing it, and then you're getting a movement monitoring report every week saying the building's moved another 15 millimeters, and you kind of, you have to kind of check what you expected to happen and what actually happens. This is Honourable Society of Lincoln Inn Fields, an advocacy block, bunker-style teaching facility hidden under the listed lawns. So this is kind of, no one knew. We'd been there for the last 5 years, but it was before and after, no difference apart from the glass roof light. Keble College, another one. This was putting a student halls around the existing campus and keeping this listed building in the centre whilst putting a basement underneath it at the same time. This ended up being a driverless vehicle space beneath, which enabled the funding of the project. So the big takeaway is the trend line, reusing buildings is the right thing to do. All of our new build projects, even with regenerative approaches, and this doesn't include the sequestration of the carbon in those regenerative projects, to be aligned with the RICS guidance on this, but we know we're winning. We've got to adapt and reuse the buildings, and the idea is to come in and talk to clients like university estates and say, what is the building stock you have? What are the easy wins? Can we stack another couple of floors onto these other buildings of yours? Which ones have got the rack concrete? Which ones need to be, done something else with? And in terms of our position in time now, the kind of LETI 2030 aligned with the REBA targets, So far, so good, right? But it's going to get more difficult to do that. But we are trending way underneath the target line. I don't know how this extrapolates up to actually if we're overdeveloping, but that's that's a conversation for someone else, I think. We're developing tools, but like Herbert and other people around there. We share this one freely with anyone who wants it. You can press a button, it will do all the calcs for you, so it gives you your metrics. We've now submitted about 50 projects historically to the UK Net Zero Carbon Building Standards group to try and understand where we are, so that the UK as a group can understand, okay, what's the current position, and therefore what is the target? Where are we going to go from there? The big levers on projects generally are you going to do a basement? What is your materiality, and can you reuse? So, these are big influences, and that's the kind of message that we're trying to communicate to clients. This is, if you strip back the frame and you can build a brand new facade just like the Bartlett, then this is a rapid prototyping approach to understanding how you might treat the building. This is our Bay Builder tool that we use in-house now, so this is for our facades team to have a play, do very quick concept options, get some metrics out of that. We have a similar tool in the structures group now. We are doing I would call it alpha testing at the moment. Is that right, Mark? Yeah, so this is starting to be used as a test case on some projects. You can see this is quite an obscure site, crazy footprint. What we would do in terms of the adaptive reuse approach to this would be to say, okay, what is the shape of the building form, what we're going to develop upwards, and we started to apply that to some building projects. It does involve a little bit of craft here and there because it's not the perfect AI solution yet, and we don't necessarily want it to be. We're not trying to do ourselves out of a job, but we're trying to find time to do other things. Think of new options, new hybrids, new materials, new combinations. Case in point, a project we have at the moment, which will remain nameless, the client's understanding, well, if we give it a coat of paint, what do we get out of it? Where's the value? If we try to agglomerate the two buildings next to each other, well, they've got different floor levels. We're going to have ramps. Maybe we can jack the floors. Maybe we can cut them away from the columns and sit them on a new steel deck at a different level. We're trying to be innovative, but it's low tech. It's not, beyond the means of possibility. And then you have the kind of nuclear option, if you like, demolish one of the buildings and build something else next to it. So this is us understanding and giving out the metrics. Generally, we talk about overall tonnages of material, and then we can also apply the coefficients to each of those projects as well. And this is the nuclear option, if you like. I need to find a better expression for that one, but there you go. So onto the case study. Fine. This was, I guess, it's a big footprint building, and we've not put too many materials onto this building. Infilling atriums, replacing the facade. But yeah, we probably added 10%, maybe 15% to the existing NIA, but we've rejuvenated this building, given it a new life, and it will be so much better place to learn. It really did need a bit of TLC. You can see here, I mean, the black and white sketches and the photographs from 1960s were great, but it doesn't look so good in the cold light of day. So yeah, it needed some work. It was a waffle slab. It still is waffle slab concrete, but these downstand beams you can see here either side indicate that actually the function is it's a one-way spanning waffle slab, so the primary reinforcement is running across in this direction. So the visual of this is a bit of a lie in terms of its function. We replaced the facade, so this is us, similar to the Bartlett. We've put a ladder frame on the outside. There's a stick system that sits on that. We've managed to get about 0.5 meter of footprint onto the perimeter of the building, so a bit of an extension there. These are the architect's renders. This is the new library on the right, and new entrance canopy. So when you get involved at the beginning of that project, you've got to do a lot of fact finding. You're looking at records, looking at archives, getting some concrete testing done, finding second source information, finding original drawings if you can, and trying to understand what you might do to extend the building. A lot of text here. I'm not going to get through all this. So yeah, there's a long stage at the beginning where you're understanding the building's capacity and the potential for it to be extended. This was very efficiently designed. I think a lot of the approaches to new build construction are going to be looking back to look forwards. This was using not many materials because they were hard to come by in that period, and the labor was cheaper. So it was much more cost effective for you to have guys spending a lot of time putting the formwork together for them to pour a limited amount of concrete into a very skinny piece of structure. So it was quite challenging in terms of actually adding load, changing load paths, putting plant on the roof. But we've got a fantastic set of historic information here. University estates are very good at looking after their information. The institutions are very good at that. When we have other types of clients, when buildings have changed hands several times, there's usually nothing. So this is gold dust when we find this stuff. You've got period of surveys, 3D surveys. We do concrete testing. We look at additional load. Is it going to affect any of the other stakeholders around the site? We've got a very deep tunnel there, and we're adding a very limited amount of load. In truth, there was quite a few tons of earth above these tunnels in any case, so that was quite an easy win. So increasing the loads, we ended up implementing the use of carbon fibre, which we had a bit of experience with. This is apparently the biggest carbon fibre project in the UK to date. You can see here, this is them through the process stripping off the paint finish so that you can get a good adhesive bond for the carbon fibre onto that concrete substrate. The reason we're doing it on the webbing of these elements is because it's the shear strength we needed to increase. When you see it's only the vertical sections here that we had to improve the capacity of. And this is a exploded view of some of the atrial infills that we use steelwork to redistribute the loads back onto the heads of the existing columns. And then some pictures on site. You can see here some pretty hefty elements here. These are distributing loads back onto the existing columns and then keeping the load path the same. So no real change there. Some pictures during the site phase. This is crinkly tin on the roof and then some composite deck for the floor infills. Yeah, here we go. That's the ladder frame going on. The canopy, new main entrance canopy. There's the finished article. A couple more. The sort of thoroughfare concourse. Some external views of a lovely new facade. And the library space and study area. And yes, a big win in terms of a low upfront embodied carbon, and yeah, we're happy with that.
Yeah. No. There we go. Fantastic. Right. Good evening, everybody. I'm Guy Ransom, and I'm Commercial Director of Geotherm. There are three things in life that I'm really passionate about, other than my family. The first is food. The second is real ale, and the third is ground and air source heat pump systems. Unlucky for you, you get the third. Hang on a second, let's take that back. Right. We were approached by University of West London to decarbonise their heating system. As with any project, when you look at it, no matter what the type of building, the starting point is always simply to size the box. It doesn't really matter what type of building you're looking at. All buildings are essentially a box. They lose heat. We've just got to work out the total amount of heat that needs to go into the box, and then we've got to work out how much heat needs to go into each part of the box from there on in. So obviously our first starting point was to find out the needs of our client. It's always a good idea to try and understand actually what your client's looking for. But beyond that, our next stage was to do an exact survey of every square metre of the entire building. Paragon House has 14 floors. And we went round every single floor and every single room in every single floor to make sure that we understood exactly what the heat loss of the building was going to be. We looked at the U values of the existing construction, the windows, what the wall makeup was, the air change factors, exactly what the building was being used for, what the concentration of people was, what the target temperatures was, everything, so that we could work out exactly what we need to be putting back in. There you go. I promise my understanding of heat pumps is a lot better than the pointer. Right, so having done the assessment, we finished up with a heat pump system where the overall system size was able to match the total heat loss of the building. We looked at the possibility of both ground source and air source. Ground source was going to be taking up a lot more space, and it also required a much bigger budget than we had available. There was also, as I'll take you in a couple of seconds, the minor technicality that this building is stuck right next to the M4. So sticking lots of boreholes next to the M4 we thought might have been possibly politically and construction sensitive. So we didn't do that. We stuck with an air source solution in terms of what we were going to go with. As well as working out what actual aggregate system we were going to put in. And as far as that's concerned, we finished up with 3 Panasonic 210 kilowatt air source heat pump systems. We were the first company in Europe to be using these systems for an application. And yes, we did have our fingers crossed as we started to install them. We also worked out exactly what the heat loss was of each room to make sure that the distribution system was correct as well. It's all very well when you're tackling a building, working out what your aggregate heat loss is and what system you need to be able to meet that overall. But of course, if you don't work out what every room needs, you're no further forwards. It is a huge misconception that heat pump systems only work when you have a very well insulated building. But if you go back to what I said to start with and you simply do the calculations, you work out what the total aggregate heat loss is and you make sure you're matching that from your system going in. But very importantly, you also then go room by room throughout the building that you're seeking to work on and make sure that you match your room heat loss as well. You're guaranteed that your clients are going to be happy. And that applies whether you're talking about a 400-year-old stately home or indeed you're talking about a beautiful university building. In order to be able to assess the heating system here, we had to cope with, I'm glad you feel that you get lovely information from universities. In this instance, we didn't get that much information. The distribution system had no data on it whatsoever, so we had to climb into the lofts and actually look at the backing plates of the fan coil units, and then we had to contact the manufacturer to find out exactly what the potential output of these units was in order to maximize their efficiency with our heat pump systems that we were going to be putting in. But we did all that, and we discovered that actually, yes, the fan coil units would indeed be able to work at the target temperature which we were going to, which was 50 degrees C, and that, as I said, the overall aggregate system would be fine. So what were the challenges that we had to face as we were doing this? Well, as I said, the photograph you can see at the top there, that is exactly next to the M4. The flyover is the M4. So whilst you're installing this, you've got all the M4 traffic going straight past you. I promise you the photograph next to it is not a unit that we dropped, but that's a photograph from the 14th floor. So these units, each of which weigh just over 2 tons, had to be lifted by a very, very large crane system 14 stories up onto the roof of the building. It was necessary to make sure, of course, that in doing that, the lifting process was safe. Health and safety is all. We had to make sure that the roof was actually capable of supporting the weight that we were going to be putting up there. So we put some spreader girders across to make sure that it could be put up there without any problem. Obviously, logistics. We had, as I say, this enormous crane with these very, very large units being brought in at the same time. So that had to all be tied up. But once you've got the units there, you're suddenly moving, of course, from a gas-powered heating system, because this system completely replaced the gas boiler system of the entire building, to an electrically powered system. Heat pumps are phenomenally efficient. They'll give you approximately 4 kilowatts of heat for 1 kilowatt of electricity. But it does still mean that if you've got a 600 kilowatt heat loss, at the very least, you're going to need 150 kilowatts of extra electrical power going in to make it work. So we had to make sure that we had an appropriate electrical supply taken up there, working with our wonderful friends at UK Power Networks. All of that, however, was done without too much difficulty. As I said, it was a little bit of a challenge that we didn't have any information on the distribution system, but again, there's always ways working with manufacturers to be able to do that. Not only did we put the heat pump system in there and work to a brief that, yes, the system had to be able to do the entire building, but our client, Oh Ye of Little Faith, wanted to make sure the existing boiler system was actually kept, just in case. So we integrated the heat pump system with the boiler on what we called a TCCS system, thermostatic cascading control system, which basically means that if we got a winter in London at -7, -8, theoretically the boiler could kick in to back it up. It hasn't done so far, though, I'm pleased to say. As I said, the installation was the first time that the U210s, the Panasonic units, were used in Europe. So we had to get past one or two small teething challenges. But at the end of the day, like I say, it's now taking the entire capacity and it's running exactly as should. And all of this had to be done whilst the university was still occupied, whilst the students were still working throughout. And of course, what period of time do you get chosen to install according to SAILEX projects? The winter, because it always has to be done just before March. So our installation actually started at the end of November, and we had to make sure all of this was up and running, working just within off times without disrupting students, and completed to the times. So all of that, as I said, done. There we go. So what did we manage to achieve? Well, the building is now completely heated by the air source heat pump system, and it has been since the system was commissioned in 2022. The building is absolutely as comfortable as you could wish. It's permanently monitored on the BMS system, which integrates into the heat pump system, so that all of the target temperatures are achieved throughout. Since the system was installed, there's been 395. I wish I could have done this presentation a week later, because I could have said 400 tonnes of CO2. But there's been 395 tonnes of CO2 saved since this was installed. Just to give you a little statistic, since our company has been installing heat pump systems, we've saved just over 50,000 tonnes of CO2 through the installations that we've undertaken, which is not bad. And obviously, the project as a whole, I'm nearly there, the project as a whole managed to achieve a huge progression in UWL's journey towards net zero. It was quite nice that as a consequence as well, we won 2 very pleasant awards. We managed to get the National Energy Awards Renewable Heat Project of the Year for 2022, and we got the Collaboration of the Year in working with our friends at Panasonic. What are the messages that you need to take away from this? Fundamentally, almost any building you think of can be heated by a ground or air source heat pump system. There are so many buildings that we need to tackle that absolutely could be done doing this. And I think, so many people are afraid that you have to have hyper well insulated buildings in order to be able to use heat pump systems. A brief look at the buildings below, all of which we've done with heat pumps, hopefully shows you that it's just not the case. It is very important to make sure that you have good information going into the project and undertake detailed surveying. All projects come back to GIGO, garbage in, garbage out. If you don't make sure you've got the right information in the first place, you're not going to finish up with a great project. It is vitally important to make sure that all parties within the project cooperate with each other. So often you get this kind of adversarial approach between contractors and clients and architects and whatever else. The more we can talk, the better. And perhaps if I wanted to just take a couple of messages away from this, it would be firstly that the opportunities for decarbonising buildings using heat pump systems is absolutely enormous. We are not tapping into this anywhere near as much as we should. And we are always, as a company, Geotherm, more than happy to talk to anybody about any project that they think might work with a heat pump. And we'll do that free of charge. As I said, food, real ale and heat pumps. They're the 3 things I'm passionate about. It really does matter. As we all know, global warming is a thing. It's something that we need to be very aware of, and we need to do something about it. And at the end of the day, there is grant funding around that will allow us to be able to install low carbon heating systems into our buildings. So let's take the opportunity and do something about it.
Very well done. I'm going to get to grips with this first before I... Oh, there we go. The benefit of going last at these things is I get to build on everything everyone said, and that's what I'm going to do this evening. You may know us because you probably used a Panasonic product today, be it hair straighteners, back... Do you know, we make heat pumps. So we were founded in 1918 by this fellow here, Mr. Matsushita, and this principle here is something that continues to drive our business. So we understand that we have a responsibility as a company to dedicate our business towards improving lives. The first product we ever introduced as Panasonic was a bicycle light so that people had less bicycle accidents. And we've continued with that and improving the quality of life of people through our products. A little bit on renewables. So as a corporation, we are going to reduce our carbon emissions by 2050 to net zero. That is equivalent to 1%. Pretty much. So that's why it's so important for us to retrofit and look at decarbonising estates. Oh, go back. One of the important parts of retrofit is that 80% of the buildings that will be standing in 2050 have already been built. They're buildings that already exist and require deep retrofits or require solutions. Oh, there we go. Building on what Aylin said to open up is university estate. Not as simple as just an office building or just housing. They're a combination of everything. So this is a model perhaps of what a university estate could look like. So student housing. Many people in this room will have experienced the joys of social housing in their youth. But social housing itself, student housing is a very varied creature. So you can have everything from one single occupancy dwellings to large occupancy dwellings. We have to have solutions for everything involved in that. University estates, as we've seen this evening, can also encompass studios, office buildings, and that's where our big buildings come in. We need to have a solution for all elements of this estate. And if you forgive me, I'm going to do the classic thing of walking across the stage. So, as guys discussed earlier, our large, we used to call them chillers. I have to put £1 in the swear jar every time I do that now. So they're reversible heat pumps. These deal with both cooling and heating. As we've all seen in central London in the summer, being inside one of these big office buildings is arguably one of the worst places to be. So we have to have a solution that will both cool and... Something else, data centres. Universities traditionally were just places of learning. Now they've become places of storage, data storage. It's a situation where the vast majority of universities were not built to have specifically temperature-controlled areas for data storage. That's now a huge part of university estates, and that's where precision air conditioning, cooling comes in and is a real consideration. And all the other bits down the bottom as well about refectories and smaller office buildings. But what I'm trying to get at is the nature of universities is changing. The nature of these spaces is changing. When the vast majority of these buildings were constructed, they weren't designed to deal with these modern issues. As we discussed earlier, COVID has changed a lot of the way we view universities and we deal with university estates. Buildings that were once designed to only house offices may now have to house large seminar rooms, data storage centres, abilities for virtual learning, as we've shown with some of our projects earlier as well. Creating spaces in which they can be, what's the word I'm looking for, adaptive and adaptable, and that's really important. And as well, going forward, so I'm actually going to skip back slightly. So change. So, as we've discussed, different products for different solutions. But a key part of this is reducing is reducing costs and creating savings. So the products that we have created are, as Guy says, incredibly efficient products. We're all very focused on global climate change being imminent and impending, but the vast majority of universities want to see a saving, want to see if we're spending £10 million, we want to be able to see a saving year on year, and that's why we're making our systems as efficient as humanly possible. But also within that is making systems that are genuinely as good as they can be. So RT90, which is a natural refrigerant, replaces across our range a lot of our previously ecologically damaging refrigerants. And it's important that the decisions we're making take into effect that. This on the end, and I'm going to touch on this very, very quickly, is hydrogen. So within this space, we're hearing a lot about hydrogen fuel cells, hydrogen boilers. This is a hydrogen fuel cell. We've had hydrogen in the UK, we've had hydrogen as a product for at least the last 26 years. We understand that this is definitely transitioning more to the idea of microgrids. So universities become their own grid. So all of these parts of the university estate require, essentially, they generate their own energy through solar, they use that energy, it becomes a small off-grid solution, and that's where hydrogen fits in terms of allowing universities to be off-grid and be a part of their own microgrid. All of this wouldn't be possible, sorry, I'm going to go back. All of this wouldn't be possible without the partnerships in this room. And that's what I want to say as well, to finish up. And as the final speaker, I think I want to finish it slightly cyclically. All of these deep retrofits wouldn't be possible without every single stage. So structural engineering, architects, and then it falls to me and Guy in the technology and HVAC side to realise that. But essentially, in order to solve these problems, we have to look at it from a holistic approach of looking at all the different solutions together and communicating together in order to approach this problem. Because you don't realise why lifting a 2-ton chiller up 14 stories is a big problem until you look at the wider problem of, I'm right next to the M4, I've got 14 stories to go up. And yes, it's all context, it's all contextual. But as final speaker, I've hammered through a little bit quickly to try and get onto the discussion, but thank you very much for listening to me. I wanted to recoup some time.
Just going to do a bit of arranging.
I was a bit waffly.
Well, I'll jabber on while you do that. So thank you very much for all 4 of the speakers. I think that was really inspiring, and I think everyone's probably got lots of questions to the panel. So we'll have the speakers up here in a minute, and then you can sort of direct your questions to them. Could I ask that when you ask the questions, you decide who you want to direct the question to? So unless it's all 4 of the panel members, but that will, if you could say sort of who it's directed to, that would help us get through questions more quickly. So can I write the... Remember, yes. Brilliant, yeah. Okay.
I definitely got the options between.
Can we turn the slides off, I think, is the...
Getting blinded.
Sorry?
The name and picture of the host of the speakers on the screen.
Ah, that's right at the beginning.
Could we shuffle down a little bit and get...
Yeah, do you want?
Yeah.
Should we
Is that all right?
do a little?
Oh, turn it off.
we're turning it off.
Oh, right, okay.
We're good.
Oh, okay. Shuffle back.
Fun game of musical chairs.
Guy and Emily. Remember that? Or the architect, the engineer, the structural engineer, the mechanical engineer. Okay, great. Can I? What's that? We've got a microphone coming.
Does that work? It does. Okay. It's a question for the whole panel. But it's a quick question generally on standards, how standards inform retrofit as much as any other building, and which standards are preferred, BREEAM, LEED, others, in determining whether your building systems work the best for their situation. which is the preferred system?
Well, I can be pretty quick on that. It's really sort of depends on the project and the brief and the use of it as well. I mean, for the Bartlett, which finished 8 years ago now, actually, it was BREEAM was the key, but obviously beyond the standards, there was the real sort of drive to try and reduce embodied carbon and waste, and a more sort of holistic sustainability strategy as well. We've delivered the Heris project, which was a refurbishment of the Broadcast Centre Olympic Park. That was a SCAR standard as well, which recently sort of established at the time higher education standard as well for refurbishment projects in particular. But I think it really depends on the context, the brief, the challenges that each of those things present. But
as a structural engineer, I was never a huge fan of BREEAM. It always felt like we didn't have much to say on the subject, and it was all about how many bicycles you could get in the basement. But there are so many faculties now. You've got Letty and Reba and the UK GBC. Sometimes it feels like the boxing. You've got the WBO, the WBC, the WBA, and they're all talking across purposes about the same topic, really. So I find that quite challenging, and I don't know who to pick. I mean, pick one and read the jargon and try and find out where the key hooks are in all of that. But I think as engineers, what's interesting for us now, having got to this sort of quantifiable position, we love the numbers. So suddenly we've got something to talk about, and that's great. It's really exciting times for us. That's kind of where I come in. And a lot of these memberships and clubs and targets, the loopholes that we've got to get through, there are so many of them that I find it difficult to understand where to look, really, frankly. They're all talking, they've all got their brochures, they've all got their infographics. It's like you're sort of rabbit in the headlights at some point, and I feel like it's interesting that they're allowed to keep breeding, frankly.
I guess as heat pump installers, our job is really interesting because we just get these guys to dictate what standards they want to work to. Our criteria are always just to make sure that we can make the biggest impact on carbon reduction that we can whilst keeping the buildings to all of the target temperatures. And if we can do that whilst managing, we tick all the boxes that we're given from these chaps at the same time, happy days. But as I say, if we can walk away with a 70% carbon reduction relative to what it was previously, that's a pretty good job done as far as we're concerned.
As manufacturers, we just have to comply with absolutely everything. So when it falls down to it, as you say, we have to be as stringent as humanly possible to comply with EU, UK, US, Japanese rules. So we're very stringent when it comes to Panasonic with safety, as I discussed, RT90, propane. Everyone gets a little bit scared when we mention propane, but I can guarantee we're a lot more safe about our propane than the vast majority of people are here with having it in their gardens and their barbecues. So don't worry.
Great, thank you. We had a question up here, I think.
Regarding heat pumps and similar kinds of technologies, I'd be interested to hear if you can elaborate on how the equipment itself, the ecological impacts of manufacturing and maybe reusing like circular opportunities for that equipment and the gases, and how that could be improved on in the future with new technology.
Do you want to take it from
Yeah,
a manufacturing point of view?
I'll go from a manufacturing point of view. So as we discussed it, as Panasonic, as a corporation, we have to be net zero by 2050, and we're committed to that. We have a pilot project in Cardiff, which is starting this year, which will be a completely off-grid factory. So that will be entirely powered by hydrogen fuel cells. We've taken it upon ourselves and our entire supply chain to reduce our carbon as much as humanly possible. As you've seen, the transition towards low GWP refrigerants is a reflection on that. So wanting to ensure that our manufacturing process and what we put into our units is as thought out as possible. A part of the benefit for us as Panasonic is 98, 99% of what goes into our unit is manufactured entirely by us in our own supply chain. So it means when we say about being net zero 2050, we have that reassurance because we have control of our supply chain that it's within house. The other thing for us is, as a global corporation, having manufacturing centres near where we're supplying. So we have European manufacturers of heat pumps. Our large heat pumps are made in France and Italy. Our domestic ones are made in the Czech Republic. So we're cutting down on that transition time. So as much as we possibly can, we're trying to look at look inwardly at ourselves from the net zero side of things.
And I think probably from an installer's perspective, we'd say that the life of a heat pump system, if we scale this back a bit and you actually look at sort of your smaller systems, domestic systems, a heat pump system will last typically between 2 to 3 times as long as a boiler. So you've got economies in terms of carbon for the manufacturing on that. A ground source heat pump, if you put a ground source in, typically the ground source itself will last 30, 35 years. The ground loop that you're putting in to feed it is, once it's installed, kind of there in perpetuity. So, you know, you're getting enormous benefits. But as I say, beyond the fact that the heat pump system itself lasts longer, obviously, once you turn the thing on, the fact that you're using 70% less energy than you would be in the first place, and hopefully that energy is coming from clean electricity as opposed to gas or oil. You know, we know that the alternative on electric heating that scarily so many buildings are still embodying these days is electric storage heaters. But, you know, the math is really simple. You put an electric storage heater in, if you're lucky, you get 1 kilowatt of heat for 1 kilowatt of energy. You put a heat pump in, you get 4 kilowatts of heat for 1 kilowatt of electricity. That's pretty straightforward.
Question at the back.
I could probably just say it. It's a follow-up.
We're being recorded, so...
Okay, thank you.
Sorry, my follow-up is in a way the same question, but in a slightly more brutal way, which is, do you have EPDs for all your units in the distribution system? Because without that, we don't know the numbers, actually. So do you have an environmental product declaration showing the lifetime carbon for your units?
Yes, we do.
You do.
And if you want to come see me
Yeah.
afterwards, I'm happy to provide.
No, because it's a frustration
Yeah.
that the architectural side of things in that regard is a lot further than the building services. And a very frequent question from people who are interested is, well, we're used to naturally ventilated buildings. You're putting a load more plant in.
Yeah.
Show us the implications of it. And often we can't, which is really annoying.
Yeah. No, I completely understand. And that's something that we had been asked for a lot more in terms of embodied carbon and life cycle of carbon as well within that. So it's something as a company that we've commissioned and we now have it purely for that reason. Is we believe it's really important to be transparent as much as humanly possible, both with the building and with those around it. So yes, happy to provide that if you would like it.
Any questions? Here?
With this move to air source heat pumps or heat pumps generally, one of the things that seems to be said a lot is about the resilience of the network to be able to provide that electricity.
Yeah.
And if we keep going, surely it gets to a point, particularly places like London, where the supply is just not going to be there, and therefore it's going to make it much more difficult to do things like these retrofits on
You're absolutely correct
sources.
that the capacity of the network at a localised level, let's just start off with that, is a challenge. But I will say that part and parcel of everything we do is we have to work very closely in partnership with UK Power Networks. And so far they keep up with what we're doing. So, you know, I mean, we've just converted a large leisure centre in East Anglia away from to whopping great, is that a technical term? Whopping great gas boilers to 3 210 kilowatt air source heat pump systems. And we've put a new transformer in to power that. But, you know, to be honest with you, it was a transformation from the transformer that was necessary to do anyway, because the leisure centre also wants to put in EV charging points and stuff like this. You know, we've got an electrical network which across the country is probably 50 years out of date. If putting in heat pump systems puts a bit more pressure for this to be accelerated, all I can say is happy days. Because goodness knows we need the network to be upgraded for all the other stuff that's happening as well, very much including electric vehicles.
I think as well there's a massive transition away from natural gas and from gas powering our largest installations. One of the things we've seen, so one of my jobs at Panasonic is I work quite heavily with our social housing sector, and that's where we're seeing a mass change in heat pumps occurring, and a mass change in heating occurring. But UK Power Grid is needing to respond to that and needing to upgrade is mainly what we're seeing as a constraint. But we're stuck, I think, as a country in a bit of a catch-22 here, is we can't upgrade until we have the infrastructure there. But our infrastructure and the cost of these installations is contingent on moving away from natural gas. So we're very much caught between a rock and a hard place slightly of needing to do so but not having the ability to do so. But the one thing I would say is you won't see the cost of electricity come down or more generation of clean electricity until we have more of a transition away from natural gas. And that's really important, especially for our own energy security as a nation.
Just one very small point, as an after if I can as well. We do quite a few social housing estates, and as I alluded to, we find that there's a lot of their social housing estates that are actually heated by electric storage heaters. So if you look at the amount of power that's going into that housing estate for heating on electric storage heaters, I put my heat pump system in and suddenly I need a quarter of the power.
Saving you.
The other thing I found recently with some of the universities is they're looking back at district heating schemes, and certainly in Camden are now looking at the universities being able to connect back onto district heating.
Yeah.
So where is the solution there in terms of...
Heat pumps and district heating are the most wonderful bedfellows going. Yeah. Either using large air source units and then distributing from there, underground insulated pipework or whatever, or sometimes we set up separate plant rooms with ground source systems as well. But it's the easiest thing in the world. And to be honest with you, when you're doing heat pump systems, you really do benefit from economies of scale. Yeah. So the bigger system we can put in, then leaking into a district system, the better. You can do all the heating and all the hot water at the same time without any problem whatsoever. I mean, we've done blocks of flats as well, which obviously is a vertical district heating scheme, funnily enough. Yeah, it's the easiest thing in the world. It really is. I should be saying it's really, really complicated because we're the only company that can do it. But it's not. It's actually not difficult.
The one thing I would say, just to finish up, and I keep it brief, is we're massively behind the rest of Europe with this. There are some really, really wonderful examples of this across Europe and across Asia as well, with some of the examples we have in Japan. I think there's a lot of learning that needs to be had from pre-existing district heat networks as well, and looking at society more in the microgrid space, as I was trying to allude to, rather than just national grid.
We have a question here.
Thank you for the great presentation we have just seen from all of them, anyway, to be honest. My question to the structural engineer. You talk about the fiber, introduce fiber to the slab. Could you just give me a little bit brief about that one? And there's another question is about the high risk, because when you're talking about university, you said there is a data being left before for you to go back and you can introduce new load and stuff for your calculation. But in different building, like other old building, there is no data, especially in overseas and stuff like that. How you approach this? What's your message for that one, and how you can approach them, you and the architect as well? Thank you.
Thank you. That's a brilliant question. So sometimes we're lucky enough to find fantastic records. We find those, who knows what was actually built, right? That's a kind of second source information. We then have to go and make sure that what's on the drawings was actually built. I mean, the way things work, we don't always have eyes on, even these days, when what the contractors are up to. So there's a level of risk we have to manage throughout that process. And we go and pull a thread and we understand, okay, well, those bars are the same size as these shown on these drawings, and we have to get to a sample size with a standard deviation that allows us to say, okay, we're pretty confident about this, and that throughout that design process, from the beginning of the project throughout, we get to a point where we are relaxed about it. I mean, there's kind of a reasonable burden on our shoulders, both with the embodied carbon, but just with the reality of gravity. As structural engineers, we have to deal with that somehow and manage that as a career path. The question about carbon fibre reinforcement is an interesting one. I think the analogy of, if there's any cricket fans, cricket bat tape, which is effectively fiberglass tape. And what it does is introduce a tension element at the extreme fibre. So if you've got a cracked cricket bat, you would wrap it round, it would be good for another couple of years. It would contain that material. So you often use in columns, if they don't have sharp edges, you can run this tape around the columns because you're retaining the material, stopping it from bursting out under compressive forces. In a flat slab, in a horizontal structure, you maybe run a bead or a line of tape along the underside of the structure, and at the extreme fibre where the material is working hardest because of elements that when they go into bending they create a tension cord along the underside, that is what you're strengthening. So it's a very low-tech approach really, but it's very lightweight, and if you want to think about the embodied carbon of it, yes, carbon fibre is quite intensively high carbon, but we use it in very small amounts. So it's really focused, it's like keyhole surgery of strengthening a floor, and it's very easily done. There are some risks you need to mitigate. If someone paints over it, and then they bring in second fix installers, you've got guys with screw guns all over the place drilling holes in it, that's a worry, and we have to then communicate to the team on site, stop drilling holes in it, please, it's really important. That's quite an interesting challenge. When you're moving into innovative spaces and new trends, you have to think about those new failure mechanisms, and you have to make sure that everyone understands what the challenge is. So it's quite fun.
Fun and scary.
Fun and scary. Great. We've got one just behind.
In terms of working with clients and commissioners of buildings, how are you finding that they are encouraging or ambitious about adaptive reuse, or how are you overcoming the constraints or convincing them to go with that way forward?
In the higher education space,
Yeah.
absolutely. I think particularly post-COVID and with the UK economy as it is and has been for the last few years, university estates are looking to optimise their existing assets much more than spending on new capital redevelopments. So there's a sort of, and Aylin can probably expand on this as well, being the sort of client in this context, but there's definitely a much more open and focused approach towards optimising existing buildings for all of the reasons that Aylin sort of outlined at the beginning as well. And we're doing a lot of work with university estates in trying to understand what the existing constraints and opportunities of their campuses is. So yeah, I think, and obviously with the sort of drive for net zero as well, that's become a real sort of at the forefront of everyone's agenda, understandably. And I think to link back to one of the earlier questions, one standard I missed off is ENERFIT as well, which is the passive house standard for refurbishment, and we're seeing a lot of university clients starting to push for those standards as well in terms of a fabric first approach and trying to minimise operational carbon. So long-winded way of saying yes, it is happening. I think it's part and parcel, particularly of being in campuses like UCL and urban environments where there isn't a huge amount of room for new development. It's the first port of call is what you can do with your existing fabric, essentially.
The case in point was LSBU. The budget didn't allow for us or for the client to have the appetite to knock the building down to start with. So that's a good, happy accident that we actually ended up with the sustainable thing. They couldn't afford to knock the building down. We do have clients that come in that are incredibly interested in doing something sustainable. And then we have those that have different ideas. There is a lot of ESGs that people need to hit, certainly public companies. So they need to be aware, they need to be educated. And it's, I think also, again, back to the challenge of the different neighbours, LEED, BREEAM. There are so many that it's kind of easy to get confused by it all, even if you're inside the system. So I think, but times are changing and clients are getting switched on, and it's.
I mean, from a research point of view, I mean, I think what we've seen is that you know, that there was a lot of myths, there's a lot of myth busting where, you know, oh, refurbishment is more expensive, oh, you know, before anyone became that conscious of energy saving or carbon saving and lack of it. So I think there's been a big shift, and as you've pointed out in your projects, these are actually much cheaper than rebuilding. And the idea was, you know, you knock it down and you build a more energy efficient building. But actually, if you look at the science behind that, the savings you make in terms of carbon, you know, really don't add up. You need 50 years before that building starts getting those. So I think there's been a sort of big shift in understanding, but I think there's also other shifts that are happening, that are technology, that are way people are looking at it. The more projects we've got, the more case studies that are out there, the more people can see the opportunities of what can be done, how it can be done efficiently, how those cost savings can really be realised. And I think a lot of what the sort of speakers today have demonstrated to us is just like how much technology goes into refurbishment, as well as how much design and consideration goes into making those decisions and making things happening. You've got to be creative. It's not like a blank piece of paper, but on the other hand, that creativity has always pushed engineering to be better. I was taught, you know, I think it was the first practice I was working in, just around the corner from here, in the 90s, you know, never take the M&E engineer's drawing as said, you know, the pipes will always be too big. You just push back, and they will get you a, you know, something that will deliver just as well, but just don't accept the first drawing. You know, and I think we're still doing that, you know, and I think that's what's happening. You're saying, come on, we've got a tight space, or you've got to crane this up 14 stories, you know, that constraint is still there. But the more we push back and say we want a solution, I think those solutions are happening, and I think that's very promising. And, you know, yes, university estates are complex places, but they're also very well placed because they're looking after a large group of buildings by one client. There's one sort of estates manager, one estate team, and each that looks after that estate. So I think there are a lot of both savings that can be made, whether it's things like district heating. We're on a don't ask me the technology, but we've got 14 boreholes with in it at Oxford Brookes, and we're very proud of having done that, and it heats the whole university estate. And pretty efficiently. I think it's the warmest I've been in my office for a long time. But you know, there are also lessons that learnt in one building can be transferred very quickly to other buildings within that estate, rather than waiting for a journal article to come out, or So I think there's a lot. You know, things can happen very quickly. So I think they also become showcases for how this all can happen. We're almost up at time. If anyone's on panel or on the floor has sort of one last, I sort of hogged the last few minutes, but
I think one last question will be nice.
Can I have the last question? Of course.
I just wondered, I loved the whole thing, by the way. I learned a hell of a lot tonight. But there was two things that made my hair stick up. One was about the use of wood. How we use wood in buildings, old buildings. Thinking particularly about cross-laminated timber, particularly. But I'm also interested to know a bit more about the issue with listed buildings. Because the town where I live, we've got a few of those. And if you mention it to the people who run the town, they all look scared because they think there are these rules. So I just wondered how you get over those issues, particularly with buildings that are that old. Thanks.
Do you want me to take it from a heating point first on the listed building? Okay. Out of the roughly 1,000 installations that we've done, I reckon some 200 of those are probably listed buildings, including 9 stately homes. so 200-300 years old. One of the great things about a heat pump system is that it works at low-level steady-state heat, which is one of the reasons that you are warmer than you've ever been before. And therefore, you can actually work with these buildings that have a surprisingly high heat loss because you are just steadily putting this heat in at a low level, as opposed to putting radiators up to 80 degrees. We actually find that the rate of leakage on these is far less than it would be at high level heat. So we can integrate heat pump systems into listed buildings with very little invasive work at all. We don't need to change windows, we don't need to change doors. Yep, if there's stuff that can be done in roof spaces and such like to minimise the loss, we'll do that. But there's absolutely no problem in integrating a heat pump system into a listed building.
But could I just add on to that, that as a sort of heritage professional, that actually a steady heat is much better for historic fabric. You know, a low steady heat is actually a much better environment, and particularly museums, National Trust properties. You know, this is exactly what they've been looking for decades, and just not had the technology to deliver it cost effectively. So
it's not just steady heating and heat pumps create a healthier building, as Aylin and Guy have said, but it also creates healthier spaces for people to live in and work in and operate in. As you said, you're warmer, but you're not getting that fluctuation in heating and cooling throughout the day as much as you may have seen previously. I know I was guilty of this in my combi boiler at home, of cracking the heat on as high as possible, getting really hot and then turning it right off. We see a lot with universities, specifically student housing, that stable heating is creating a much more, and stable cooling is creating a much healthier environment for people to live in, much better air quality, much better for people to exist in. So I think that's a really key aspect of it. If anything, it's making our historic spaces better and preserving them, I would think, for longer. Let you guys deal with the timber side.
I didn't think it was going to pan out like that. I didn't realise you're going to be able to sell more crowdsourced heat pumps out of that question, but you switched it.
Oh, if there's one thing you know about me, I'll always sell an air source heat pump.
The thermal mass of timber, wow.
Yep.
So, I mean, you know, I'm not sure we have enough time for me to answer that question, but, you know, there's a lot of people know what they're doing, designing timber right now in all types of building typologies. There are emerging statutory requirements of combustibility limitations, heights of buildings, relevant buildings, buildings that people sleep in and buildings that people work in have different treatments, different classifications. Timber is a great structural material, and it's a regenerative one. Every time someone cuts down a tree in a FSC supply, they plant 4 more. I'm not an expert on the biodiversity environmental side of that. That's something that's an interesting channel to go down. You know, there is a life around these forest situations, but it's a very good pitch coming from the timber industry right now, and there's a good talk from recycled steel, not recycled steel, reused steel, taking steel from somewhere, giving it a fresh life somewhere else. I have to say that you have decommissioned a building in doing that, and there aren't enough buildings for us to keep doing that. So I don't know how much mileage there is in reused steel, because if someone's got to demolish something to reuse something, yeah, you've not created something, you've also demolished something. So I still think the use of timber is still the winning horse for me, but there are other products, there are other innovations, there are other materials that we haven't discovered yet. There are the unknown unknowns and the known knowns, and the things we know about timber are good. So I think
Okay. Thank you very much,
good.
everyone.
Thank you.
So just on behalf of the Building Centre, thank you everyone who came this evening, and thank you to Emily, to Guy, to Duncan, to Tom and to Aylin as well for talking tonight. So thank you all from us at the Building Centre, so thank you. I'm sure some of you would like to put your questions to the speakers personally, and we request that you could do that upstairs in the exhibition. As I said earlier on, it's open until 8 o'clock. So I will invite our speakers to make their way upstairs to the gallery. So do feel free to join them if you can. And if you'd also like to get inside Bartlett and London South Bank University, the examples you've seen, we do have 2 tours of those. So South Bank is on the 26th of June and the Bartlett on the 4th of July. And we've got more events. We've got an event on the 15th of May back in this room about community design and retrofit. So if you can make it, please do book and join us for that. So thank you again.